I myself, my name is Abhijit. You can call me AB. I've been dealing into corporate training since now 10 years and have delivered corporate trainings to most of the tech giant companies that we hear about today, be it Cisco, be it you can say Airtel in India, be it Paytm, be it Colt, be it various other tech giant companies that actually deals into service providers. So when I talk about my experience, my prior experience has been in the field of routing and switching. Then I learned something about security, some things about data centers, some things about uh, service provider networks. And then I started delivering trainings into these domains. And then when Cisco came out with the new launch of certifications, I recently then grabbed my interest into automation. And since I had decent skills about how programming works in Python and things like that.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
I picked up those particular hot topics of cutting edge technologies and then started learning about the solutions that were being introduced. So be it SD-WAN, be it SD-Access, ACI, and a lot of other things. So we've been dealing into this trainings for these cutting edge technologies that actually connects the internet today. And since every application that we see nowadays has a lot to do with how different, I would say, headquarters or offices, which are situated all over the world, can be connected. Since the pandemic has affected and it has kind of introduced us with a new normal, almost every company is looking forward to connect their offices seamlessly with each other. So be it your offices situated in Europe, and then you want to connect them with Middle East or Asia Pacific region or somewhere else. Your network connectivity needs to be seamless, and that's why every company is looking forward for implementing solutions like SD-WAN, SD-Access, and things like that. Out of those solutions, out of those cutting-edge solutions that everyone is talking about in today's world, we will be discussing how SD-WAN works. We will be discussing about what do we have for you guys, where we will talk about how the solution is going to help you in your career perspective as well and enhancing your current skills as well. And if I tell you about what do we go with or what are the most important things that we need to discuss in this particular webinar, then you can say that the webinar is purely being conducted for the topic of SD-WAN. Okay, and then we're talking about Cisco's SD-WAN or Viptela SD-WAN. Both of the things are same over here. And the major important things that we have in this solution is something you can say SDN. So you need to have a solid understanding about what SDN is. SDN stands for software defined networking, and that's what SD-WAN is based on. Once you're good with SDN, then we talk about SD-WAN components, right? So we have things like vManage, you might have heard about. We have things like vBond. We have things like vSmart and things like I would say Edge, or we can say C-Edge, but rather we can just call it as vEdge. So these are the components that goes into the solution, and definitely it has a lot to do with in comparison with the traditional networks. So if we talk about vManage handles something which is called as management plane of the fabric. vBond handles a newly introduced orchestration plane in the fabric. vSmart, however, is the brain which handles the control plane, and vEdge is something that handles the data plane. That's how the solution has been divided. And once you're good about that, once you are okay understanding how these things works, you need to dig deeper into understanding how control plane and data plane operations works into the fabric or into the SD-WAN solution. And then we talk about how SD-WAN onboarding is done and how you fine-tune the solution with the help of something called SD-WAN policies. This is purely major things that you need to be aware about, or that you need to have a decent knowledge about to call yourself SD-WAN expert. So I'll give you a glimpse about all of these particular things that we have in order to get introduced with what SD-WAN is and why do we need SD-WAN ad hoc, or you can say this is a need of the hour where everyone who is dealing into networking at least needs to have the knowledge of, you can say, SD-WAN. So let's see how that goes up. And if I give you a glimpse about why companies are moving towards a solution like SD-WAN. So the story actually starts with something you can call as SDN. So SDN is a technology that was introduced around like 10 years ago, and the concept is about making changes into how the traditional network actually operates nowadays. So if I give you a glimpse about that, generally what we have, let's say if I tell you about the current scenario. So we have our routers, we have our switches, we have our firewalls, we have our load balancers, and a lot of devices, okay, that we use into our fabric or that we use into our traditional networks. So in that particular case, whenever you need to manage devices like these, what do? You can actually use, for example, a router, then connect that particular router with a PC and have something like PuTTY installed on that, and you can get an access of the CLI, command line interface, and configure that router. Or you can have that router connected or exposed to internet, and then there is a remote user who actually tries to SSH onto the device. That's what you can do, and still get the access of CLI and configure the device. That's how you work with normal devices. What if you have things like ASA? If you have a box of ASA, which actually has multiple ways about how it can be managed. One way is you can manage it via CLI. The other way is you can manage it via GUI, which is called as ASDM, Application Security Device Manager. That's another way that you can manage. So you can either use it or access it locally, or you can expose ASA as well to the same internet, and the remote user can try to communicate with that by using a protocol called HTTP, right? Because ASDN can be exposed and accessed by using HTTP. That's how devices works. But these devices into the traditional networks has a lot to deal with. For example, if I give you a glimpse about a router actually needs to do the forwarding of traffic, and then it also needs to take the decisions about how the communication needs to be done, which are the best route that needs to be installed, and lots of other things. For example, if we have a scenario like this, let's say that we have R1, then we have R1 connected to R2, and that is connected to R3. And then we have multiple routes, R4, and then R5. And then these routes are there. Now, there is a loop back onto R3, which is called as 30.0.0.0/24. And there is a loop back onto R1 that is 10.0.0.0/24. And we are assuming that this entire thing is in OSPF area 0. So how that's going to work? Because the R1 actually has 3 neighbors, 1, 2, and 3. The R2, R4, and R5 are also going to be neighbor with R3. And since R3 is advertising this network out, this particular network is going to be known by R3, by R4, and by R5. So I can expect that on all of these three routes, I can expect an OSPF route for 30.0.0.0 having the next hop as R3, correct? And the same route is going to be propagated out towards the R1 by all these neighbors. So R1 kind of receives three routes. And that route is actually stored into something called LSDB, link state database. And then the best route amongst that is actually stored into the routing table. Make sense? This is how you actually end up getting the best route. Depending if the metric of all those routes are same, your R1 probably might see multiple routes for reaching out to the destination, correct? But all of these decisions actually needs to be taken by your router. And for that, there is a lot of utilization of CPU and utilization of memory and a lot of other things comes into picture. So when we talk about how these things are actually done, these tasks or these jobs of figuring out the best route and placing them into the route table and then doing the forwarding of traffic based on the information that is available onto the route table, all these decisions are actually handled by different planes. Okay, so there are three major planes into the traditional network that we talk about. A, we have something called management plane. B, we have something called control plane. And C, we have something called data plane. So management plane, control plane, and data plane is something that we have. Now, when we talk about management plane is majorly about taking access and doing the configuration, which means it is directly correlate to CLI. I mean, when you access CLI, you're doing nothing but playing with management plane. After accessing the CLI, you actually deploy some configuration onto the device by using CLI commands or GUI interfacing. So when you deploy a configuration, you are doing nothing, but you are manipulating the CPU, okay, of the device, be it a router, switch, firewall, or any other chip. Then once you manipulate the CPU, or you tell the CPU that this is how you need to serve, this is how you need to operate. Whenever you receive the routes, you install it into the route table, calculating the best route. Okay, and how do you tell that? You're basically telling that to the device by using OSPF as your part of configuration. And then if you talk about data plane, once the CPU is configured, then CPU also gives the information to data plane based on which the line cards that are there onto the device are affected. So whether the line card, whether the interface, be it fast Ethernet, gigabit Ethernet, 10 gig Ethernet, whether those interfaces are going to forward that traffic or drop that traffic depends on the information that is there into the data plane. And the data plane information is actually given by control plane. So you access the CLI and you configure the CPU, okay, like this. You have a PC, you access the CLI, configure the CPU, then the CPU tells the information right away to the data plane that this is how you gotta behave. And then the data plane actually tells the line cards to accept the traffic or to drop the traffic. That's how these planes work with each other in order to get that thing figured out. And that's how the entire network works. Okay, forget about the BGP neighbor down that Facebook introduced lately, but this is exactly how the internet works. Their management plane was all good. So when I talk about this, there is still a flaw. This is something that we actually know about. We call it as traditional network or traditional networking. Now, how can we say that? I mean, this is a perfect, you can say, dish that has been catered by network engineers lately over the decades now. But still, the world is experiencing some drawbacks of having a network infrastructure like this. So that's why they are moving from traditional network to SDN Centric network. Now let's try to understand what SDN Centric Network is. So if I give you a scenario, for example, let's say that we have an ISP, and that ISP is basically connecting our multiple offices. So we have an office there in London, and then we have an office there in Dubai. Okay, and we have some routers and then lots of devices where our employees are sitting up. And then we have another router and lots of devices, and then there as well, some employees are sitting. And the same ISP is actually connected to something we can call our headquarters. Let's say this is in California. And then there we have a couple of routers for the redundancy purposes. Then we have some firewalls for the security purposes. Then we have some layer 3 switches, right? Then we have some layer 2 switches. And then there are some servers, server 1, server 2, server 3. And all of these servers are basically connected in this way. And on these servers, there are lots of VMs, okay, virtual machines, which actually has applications, business apps, okay? These business apps are actually required by the people that are sitting over here in London and Dubai. And I'm not limiting the fact that they only have London and Dubai. They might have some other offices as well, which might require multiple ISPs to be connected with. So in this particular scenario, when we talk about how the communication might be done, then in that particular case, you would say that you can assume that this particular shit is your access layer. Okay, this particular shit is your distribution layer, and this over here is your core layer. Make sense? And then in order to make all, this is what we call as 3-layer hierarchical model. Okay, you also might have in this particular scenario something called spine and leaf architecture right over here. Okay, that's a different story altogether. But when we talk about this, then in order to make this 3-layer hierarchical model working, let's put up some redundancy. So you might have connections like this in the internal, okay, to make it more complex. So in order to make it working, what's happening is the business applications actually needs to be accessed by the guys that are sitting over here, okay, London and Dubai. So they need the reachability to via any of the zigzag way. That's all possible. But to make it working, you might need to configure lots and lots of config. So first of all, you might need to take care of making them connected with BGP, like how Facebook has, but with more efficiency. Then you need to have some internal communications. So let's say you have BGP config for internal, you have OSPF. Then for making the things work from inside to outside, you have NAT configurations, you have firewall configurations, you have ACL configurations, you have VLANs configured, you have inter-VLAN routing configured, you have STP configured, you have VTP configured, you have HSRP configured, right? And then lots of other configuration that goes into place. I'm not saying only in headquarters. I'm saying this configuration needs to be done over here, and over here as well. In all of these things.
So, Abhijit, till now, the question came: does Cisco SD-WAN uses OpenFlow by Deepak Mishra?
Well, it does not really use OpenFlow. It uses some other protocols. I've read that question. I'll come back to those questions once I'm done explaining from my side.
All right. Thanks.
So when we talk about this, as I said, there are lots of configurations that goes inside of your offices. and then you need to take care of how the communications actually needs to be done. But the limitation over here, this is how the traditional network works. The limitation, however, that we actually face in this particular scenario is if there is a new application that is actually being introduced. Let's say that there is a new server that is actually being placed. Now, this same server needs to be connected via these links. And then there are some applications that are installed. And these new applications actually needs to be accessed by people that are sitting over here right away. So when you talk about these, then in that particular case, you need to manipulate the configuration that you have. You might need to work with your BGP, you might need to work with your OSPF, you might need to work with your NAT, you might need to work with your firewall, ACL, and lots of other things, right? And these configurations actually needs to be done onto all of the devices that are present, because every device has their control plane, okay? And every device has their data plane, right? This is something that you need to actually take care of. Now, once these configurations are actually being taken care of, then in that particular case, you will have to apply the solution everywhere, on every device, even onto the headquarter, on London side, and on Dubai side. This kind of approach is very slow, and this is very manual. In fact, Cisco's TAC, Cisco TAC, which stands for Technical Assistance Center, Cisco TAC conducted, you can say, a survey, and then they got to know that around 95% of their customers are relying on to manual configuration. Okay, and out of these 95%, around 70% of the issues that they get is because of the misconfigs. You get that? For example, the employee that is sitting in London is not able to communicate with the employee that is sitting in Dubai, which probably might be something like the IPsec tunnel that the London office and the Dubai office needs to have is down. So in that particular case, whenever such kind of thing is down, then in that case, you'll need to see that what's the configuration that is going down, or what is the configuration that is not correct. And mostly when your local network engineers do not get able to solve the issue, then you need to report that particular issue to TAC. Suman Samar is saying repeatedly that what's the use, what's the purpose, what's the benefit, why do we need them? I don't get it. What's your question? Okay, I'll come back to the questions later. Now, when we think about the same, that how the communication actually is being done, then in that particular case, this is how the limitation can actually be introduced. So when we talk about how the you can say limitations can be addressed, then we jump into SD-WAN solution. Now we saw that this is what the limitation of traditional network is. You need to go on every single device and you need to communicate with that device and then do some configuration. However, onto SDN centric device, when we talk about a solution or when we talk about an architecture that is focused on SDN centric solution, then which is basically SD-WAN. So in the SD-WAN, we talk about a controller being there. Okay, and if you have sites, let's say this is your London site, then you have your Dubai site, and then you have let's say Singapore site, and then all of these particular sites are connected to internet. So your controllers are connected to internet, your sites are connected to internet, and then whatever devices that you have, here, here, or here. All of these devices can actually be managed by this controller. So the controller communicates with an admin PC, okay? And you tell the controller that this is the configuration that I want to deploy on all the sites. So what happens is controller has the ability of managing the control plane, and the edge devices now only get left with data plane, data plane, data plane, and data plane. You get that? This is what they get left with. Now, when you talk about something like this, the communication also needs to be secure. So what happens is you don't need to take care of configuring some tunneling mechanisms between the site. Earlier in the traditional network, if you want your London site to communicate with Dubai site or London site to communicate with Singapore site, you need to configure tunnels manually. But in the SD-WAN fabric, it is all taken care by default. In fact, irrespective of what is your underlay transport, if it's a premium bandwidth like MPLS, or if it's a commodity internet like public internet, okay, or even 3G or LTE, all of these transports support secure communication between your sites all across the globe. So as soon as you do the onboarding of your vEdges, as soon as you deploy the solution, there will be by default IPsec tunnels that will be created between the sites without any extra configuration needed. You manually don't need to do any configuration for the security of your communication, of your end-to-end or site-to-site communication. It is all taken care by default. So you automatically establish an IPsec tunnels between your sites, and that's what is actually used whenever the communication is actually done. This is how awesome it becomes. So the configuration is pretty less. It is quite smart that you can just tell your controller that this is the configuration that I want, and I want to deploy such kind of configuration onto all of my sites. And by just a single click, you would be able to push the configuration on multiple devices that you want. If you want to only deploy a configuration onto a single device, that's also possible. But the major case over here is the controller. Controller is something that you need to use. So how does all of this particular thing works when we talk about the controllers and when we talk about the vEdges? So we would be having a lab scenario in which we will be building up the topology from the scratch, where we deploy some controllers and where we deploy some configurations. And the topology is going to look something like this. So we have certain, I would say, things that we have. This is, if I introduce you about what we're going to have into our topology, we have something called controller site, okay, in which we have some of the SD-WAN controllers. One is vManager, the other one is vBond, then we have vSmart. And this particular thing over here is the certificate server, okay, which is basically based on PKI, public key infrastructure. So this vManager, however, on the back end is connected to admin PC. And then by using this admin PC, you can actually access, open up the Chrome into the admin PC and access the GUI of vManager. And you tell your vManager that this is how the communication or this is how the deployment actually needs to be done. Once you expose your controller fabric over the internet and over the any transport, so we have two transports that you can see over here. One is the public internet, the other one is MPLS. And mostly we have certain other office over here. So if you think about this, let's consider this as your London office, okay, which is kind of playing a role of your hub. Okay, then let's say this is your Singapore office, which is spoke 1. Then let's consider this as your Dubai office, which is spoke 2. And let's consider this as your Delhi office, spoke 3. That's how the scenario is actually treated. So you have a site in London, then you have a site in Singapore, then you have a site in Dubai, and you have a site in India, in Delhi. And then all of these sites are basically connected to public internet and MPLS by this particular way. And we have various other deployment models as well. It's not like that we only have some of the things that are available. Okay, I'll try to reshare my screen again. Cool. So when we talk about these, we have multiple transports over which we're using some different scenarios. So because our Dubai side is kind of acting as a hub, we have a firewall in place. Okay, that's an enterprise firewall. Then after that, we have a vEdges, and then we have vEdges 2. So these are two vEdges that actually ensures high availability. So whenever the switch 16 that is actually connected to internal LAN traffic wants to communicate with the site in Dubai, the site in London, the site in Singapore, or the site in Delhi, India, the traffic can either go via vEdges 1 over the public internet, or the traffic can go via vEdges over the MPLS, okay? Or the traffic can go via vEdges to public internet, or the traffic can go via vEdges to MPLS. You see how many transports that we have? So it can basically have the ability of using multiple transports and making sure that the connectivity is always up. Okay, and we have some of the sites where only a single vEdge is deployed, but it has connectivity over both the transports, like our vEdge number 3 and our vEdge number 4, which we are assuming that that's a Singapore office and a Dubai office. Then after that, we have a site in Delhi, which only has MPLS connectivity. It does not have any connectivity with the public internet. That doesn't have it. So how does things can be taken care in that particular case? That's also something that is being taken care of. And then after deploying the entire fabric, what happens is there are two types of tunnels that are actually built up, or two type of connectivities that are built up. One, we called something called control connectivity. And the second thing is called as data connectivity. Okay, these are two crucial things that you need to set up when we talk about control connectivity and when we talk about data plane connectivity. Then in that particular case, the control plane connectivity means the connectivity from your vEdges to the controllers. So these are your vEdges. They need to get connected to all the controllers that you have. That will be something that is going to be called as control plane connectivity. Why is that going to be called as control plane connectivity? Because the configuration on this entire vEdges will be pushed from vManage. Okay, so vManage is your central point of touch that you are going to communicate with. So you deploy the configuration from the controller. That's why you need to build up a control connectivity. And in the SD-WAN fabric, the control connectivity is built up by using DTLS tunnels. Okay, datagram or data plane telegram you can transport layer security, datagram transport layer security, and the data plane connectivity, which is going to be the communication from site to site, not site to controllers. So the vEdge 3 is going to have a tunnel, an IPsec tunnel with vEdge 4. vEdge 3 is going to have an IPsec tunnel with vEdge number 1. vEdge 3 is going to have an IPsec tunnel with vEdge number 5. vEdge 3 is going to have an IPsec tunnel with vEdge number 2. Similarly, vEdge 1 will have the tunnel with vEdge 3, with vEdge 4, and with vEdge number 5. Mind you, vEdge 1 will not create a tunnel with vEdge 2. No. Why is that? Because they are into same site. And we won't make any stupid mistake for creating a tunnel, or you can say an overlay communication from vEdge 1 to vEdge 2, because they are in same site, so there is no need as such. So all these data plane connectivity, in order to forward the traffic, is actually built up over the IPsec into SD-WAN. So these are the two type of tunnels that we actually set up into our lab whenever we onboard our fabric. Once the fabric is onboarded, then we ensure that the communication is actually done throughout the session. And these tunnels are maintained throughout over any of the transport. You can fine tune the transport by using policies such as centralized policies and localized policies in order to prioritize one of the transport. For example, if you want to implement hub and spoke stuff, which means that WAN H3 and WAN H4 being our spokes, they should not able to communicate over any transport directly. What we want is we want the communication to be done into hub and spoke manner, which means the traffic should go first to WAN H1 and then come back to WAN H4. The traffic first go to WAN H2 and then come back to WAN H4. That's how we want it. So in order to do any kind of fine tuning like that, you need to actually use policies in this. Let's see how the solution actually looks like and how do you deploy some configuration onto the fabric over here. So generally, I'll just share my other screen with you to showcase how the things look like. So this is kind of how the fabric actually looks like. I hope you can see that. And in this particular fabric, we have our vManage, vBond, vSmart, and that's our Cisco SD-WAN, vManage GUI. When I log in into that, it performs a security check. There, you see that some of the managers are onboarded. You see a control connectivity now because they say it's unreachable. Okay, let me see what's wrong. Okay, looks like. There, you see? Now, what we're gonna try up into this particular scenario is our vManager, vBond, vSmart are all our controllers, okay? And in this particular scenario, we have some advantages that needs to be part of the fabric. And you can see that the control connectivity is down. It says control down because there is no reachability. Okay, the reachability for WAN is 1, 2, 3, 4. It says it is down. And if you look at the devices, then you can see that these are the advantages that actually needs to be part of your fabric. Okay, which are part of your fabric, but they are not reachable. Now, why they are not reachable? Because the control connectivity is down. Your vManage cannot actually reach out to vManage, vBond, or vSmart in order to create the DTLS tunnel, okay, which is control pin connectivity. Once the DTLS tunnel is built up, then only the IPsec tunnels will also be built up. As of now, if I go onto my vManage 1, and if I let me just increase the font size so that I can show you. Now I'm just going to show you that how the control connectivity can actually be brought up and how that affects the fabric. So currently, if I say show control connections, it says there are no control connections, and it is trying to create a connectivity Okay, it is trying to create a connectivity with your vBond at the very first attempt, but it says that it is in connect state and the mode is decon failure. What does decon failure mean? Decon failure means DTLS connection failure. And based on that, until unless it creates, so vBond is the very first controller that your WAN tries to communicate to. Once your vBond is able to communicate with your WAN, then only the communication can be established, and vBond is going to give the information about who is the vManager and who is the vSmart after the WAN authorizes or authenticates itself with the vBond. So vBond is kind of the authenticator of the fabric. If you're not validating your identity to the vBond, then there is no chance that you're going to be entertained. So in this case, what I do is I'm just going to configure my iNet router with some basic configurations. Okay, I already have a static default router going out towards the iNet on all the WAN edges to make sure that the reachability comes up. So I'm just going to take the access of my iNet and I'm going to configure some IP addresses onto these interfaces, which would basically be done into our training from depth. But I'll just show you that how the changes works. And also, there is also no data plane connectivity with the devices. So if I go onto my vEdges1, and if I say show IPsec outbound connections, then you can see that there are no IPsec tunnels as well. If I say show BFD sessions, there are also no connectivity with BFD. So what I'm going to do is I'm going to go onto my iNet and I'm going to configure this manual, just the IP address configurations on these interfaces. So I would go and say, no, we don't want to do any initial configuration. And what I do here is I'm going to go and say enable config T. Then after that, interface, or I will just name my router something. The host name iNet, interface GI0/0, IP address 192.120.2.255.255.255.0 description connected to DC switch. Okay, this particular link GI0/0 is connected to DC switch. So I'm going to configure that. Then after that, there. Then after that, I'm going to say no shutdown and take an exit. Once it's good, then I'm going to go into my interface, IP address 192.1.1.255.255.255.0. Description connected to vEdges2. No shutdown, take an exit. Actually, I think I did the wrong IP configuration here. It needs to be 192.120.1. So I'll just go and say interface GI0/0, IP address 192.120.1.255.255.255.0. Exit. Then I'll move on to the next GI0/2, IP address 192.1.2.1.255.255.255.0. No shutdown, take an exit. Then interface GI0/3, which is connected to vEdges3, IP address 192.168, 192.1.3.1. No shutdown, take an exit. And interface GI0/4, IP address 192.1.4.1. No shutdown, take an exit. And that's all. Once we have all of our interface configured, when I say show IP interface brief, you can see these are our interfaces configured. They are all up and up. Now, if I say show IP route, what I need to do is, in order to reach out to my controllers from my iNet router, vManage, vEdges, and vSmart, which are configured with 223 subnet, I'm just going to throw a static route towards the DC switch. So I would go onto my iNet and I'll say IP route 223.110.255.255.255.0, facing towards the DC switch. And if I now see show IP route, You can see that there is a route 223.110. Now, when I try to communicate with my controllers, ping 223.110, which is vManage, there you go, 11, 12, and 13, which we don't really require, but yeah, we're all good. Now, the communication from iNet to the controllers is all set. Now, when I go to vEdges 1 and try to communicate 223.110, which is my vManager, there you go. You have the reachability. 11, you have the reachability, and at 12, you have the reachability there, which means all the connectivity is up. And when I try to see now, show control connections, there you go. You have all the connectivity up and running, which means that it has created a DTLS tunnel with vSmart, vBond, and vManage. And you can see the state of that is up, up, and up. Okay, this is your vEdges 1 creating control connectivity. And if I go onto our GUI now, you can see automatically it went to control up for all of those 4 vEdges that we have onboarded. Make sense? And as a result, you have a full WAN connectivity on 3 sites. Which are these 3 sites? These are site number 12, okay, site number 3, and site number 4. Which in our topology, this is site number 12, that's your site number 3, and that's your site number 4. Of course, we have site number 5 as well, but we have not onboarded that due to some reasons. And then there definitely is backend LAN traffic that needs to be set up. Now you see, I just ensured that the connectivity comes up. And then when I go back to my vEdges 1, and if I see show IPsec outbound connections, there you go. You have 2 IPsec tunnels going out from vEdges 1. One is going towards 192.1.3.1, which is basically vEdges number 3. And one is going to 192.1.4.2, which is your vEdges number 4. vEdges number 5 as of now is not part of the fabric. vEdges number 2 is part of the fabric, but vEdges 1 is not going to create an IPsec tunnel with vEdges 2 because they are in same site. Okay, so there is no one who would want the same site communication to be done by going out and then coming into the same site. So that's why it's not going to be done. But if I take the access of my vEdges 3, let's see how it goes up. Change settings, appearances, change it to 14. Okay, and apply. Admin, and then admin. When I log in, and if I now see show control connections, there you go. vSmart, vBond, vManage all up. Show IPsec outbound connections. There, you see, your vEdges 3 has an IPsec tunnel with vEdges number 1, vEdges number 2, and vEdges number 4. Make sense? So this is how control plane and data plane connectivities are actually maintained into your vManage solution right away over here. So you basically go and you communicate and you deploy policies, security policies, and lots of other configurations directly from here. Make sense? If you want to deploy some configuration, you can do it centrally. If you want to access your vEdges CLI, you can just go to your SSH terminal and you can say that I want to communicate or take the access of vEdges 1. You hit there and you're right over there. You can get the CLI access of your devices right away. Here, I can just log in by saying admin, and I'm in. That's how beautiful this GUI has been created. In the main dashboard here, you can get all the information about the current statistics of how your fabric is working. And this, my friends, is nothing but the SD-WAN in a very limited way. Definitely, we're going to deploy lots of other things into this fabric, and we will see how the onboarding is done. There won't be any topology in our class, which we have it deployed already. We ask our candidates to come up with the configuration plain blank. So when we talk about this, the configuration is pretty neat and clean that we do. Now we can take the questions. So Dipanshu, if you have notified, or Nitish, if you have noted down any questions, please go ahead and ask them. I, however, will be sharing my other screen.
All right.
I'll just go through the questions again, though. So Vishal says, with this course, we can qualify. Definitely. Whatever content that we're going to cover in this particular training is completely from the exam blueprint. Then Urmila says, do we have any dedicated routers or devices to configure for SD-WAN controller? Well, we are going to give you all the dedicated lab accesses. So we have unlimited lab accesses in our courses. Every individual candidate who signs up with us gets their own lab, their own personal lab. So you kind of access our infrastructure that is in our data center, and you can build up your lab by accessing it from remote. And that's for unlimited time during the course. Then can we say, Brian is saying, can we also say vBond is the brain of the SD-WAN? Well, vBond is not the brain of the SD-WAN fabric, Brian. It's the vSmart. vBond is just something that actually validates whether you are legit to become part of the fabric or not. If you are legit, then you can definitely become part of the fabric. Otherwise, there is no place for you in the fabric. Once you prove your legitimacy, then vBond gives the information about the brain and the other organs, or you can say heart. So then vManage then creates a control connection with those particular vManage and vBond, and vSmart once it proves its legitimacy to the vBond. Then Rohit, okay, that's fine. Difference between vManage, vBond, and vSmart? Well, vBond and vSmart are part of the controllers. Okay, vBond handles the authenticity, vSmart handles the deployment, the policy configuration, whatever configuration that you're going to push onto the edge device, it is going to be done via vSmart. So you can say that vEdges are nothing but the routers that are placed at the edge of your at the edge of your branches. If you have a branch in London, you're going to have a vEdge there. And if you have a branch in Dubai, you're going to have a vEdge there. Both of these vEdges needs to communicate with a controller which might be situated anywhere else. Santosh is saying, if suppose we implement SD-WAN controller in HO, the BO office needs any additional hardware to connect the SD-WAN controller. No, not any extra hardware are required. You can actually connect to the same devices, whatever devices that are actually being used into your fabric as of now as the vEdges. Same devices can become part of your SD-WAN fabric. You don't need to scrap the old devices. You just need to upgrade the iOS to make it SD-WAN compatible. That's all. There is Sheshagiri is saying that is there any technical dependency to get through the SD-WAN course? Well, I would say very limited knowledge needs to be there. If you're good with your routing and switching skills, if you know how to create BGP neighborships, then that's all. Nothing else needs to be there. You don't need to have any MPLS knowledge. You don't need to have any SD-Access, SD-WAN knowledge. That's all fine. You just need to have a good understanding about how routing and switching works. We don't need to configure MPLS into our fabric. We're going to have an MPLS router in which we will be using BGP as the underlay. There is a misconception, however, Dipinder is saying how MPLS and SD-WAN are compared. Mostly people say that SD-WAN is the future, but MPLS is a service and SD-WAN is a company. Yeah, that's correct. So there is a misconception in the industry that SD-WAN is going to replace MPLS. It's not the case. MPLS is type of, you can say an underlay that is actually used in order to connect your different sites together. SD-WAN is using MPLS as one of the transport. SD-WAN is not going to replace MPLS. MPLS is still going to be used by SD-WAN. What about the implementation of multi-vendor SD-WAN environment? Well, that's quite hard. SD-WAN, whenever we talk about multi-vendor SD-WAN, then it is quite limited over here. Your Juniper devices, your Citrix devices, your Sienna devices, they cannot become part of your Cisco's SD-WAN family. So it's quite limited over here. You need to use the devices that are allowed to be part of the fabric. Now, the upcoming batch schedule, I'll just highlight that as well into, there. These are our upcoming trainings that we have. These are my exclusive upcoming batches that I have planned in order to be executed at PyNet Labs Private Limited. So we are coming up with these batches, whatever suits your schedule. You can enroll for these particular batches by getting in touch with our executives, Dipashu and Nitish, and they will help you through all the requirements that you need to fulfill in order to book a seat into our training. We do have limited seats. We don't go with maximum number of candidates. We hardly go with 15 or 10 to 15 candidates per batch, so that the doubt solving can actually be given importance. Well, we are going to come up with SD-Access labs as well. Yeah, but that's pretty soon to be announced now. Apart from that, if we talk about more questions.
One from Deepak. Can you check once? Just let it scroll up. Just do the config on controller. It will implement on other routers. Is it correct? I'm not sure if
config on the controller. Yeah, that's correct. That's correct, Deepak. And we're gonna see that in action as well in our labs.
All right, guys. So any questions that you have for us? Okay, we have one more question from Madan. Abhijit, please check what's benefit.
What benefit will get out of SD-WAN when we use SD-Access? Well, SD-Access and SD-WAN both are different solutions. You cannot compare them together. SD-Access manages more of a LAN side. SD-WAN manages more of a WAN side. So these are two different solutions used for two different kind of infrastructures. They shouldn't be compared at all. But both of them are based on SDN. So ACI, NSO, SD-WAN, SD-Access, all of these solutions are actually part of the SDN, software defined network. Yes, there are specific hardware that needs to be used for SDH. The tunnels that are built up are IPsec tunnels. So for, you can say, more details, you can get in touch with Mr. Nitish at this particular number, or you can either, I think, go on our website.
It's 9821215002. But there is another question from Mr. Mujahid. Is SD-WAN replacing MPLS?
No, it is not going to replace MPLS, as I told you. It is going to work with MPLS. Mujahid, SD-WAN is not going to replace MPLS. MPLS is still going to be used. MPLS is one of the transport that is actually, you can go through our websites as well, guys, for getting in touch with our candidates. You can just drop your message over here and someone will coordinate with you as well. But for more details directly, you can contact on this detail.
And there is another question from Bitu. I'm not sure if you addressed it, Abhijit. Is it for policy? What are the things do we need to know about our traditional routing and switching?
Yes, in order to deploy policies, you should be good with routing and switching skills. And you should know how your fabric is working, because policy is all about influencing how the infrastructure can actually be used from LAN side to WAN side. So yeah, routing switching needs to be there as a good knowledge or as a handy knowledge for your traditional to get to know about policies.
Is there any specific hardware for SD-WAN at the edge from Manoj?
Yeah, as said, it is going to be specific about that.
Okay, clear. Okay. And one question came was, what are the concepts that will be covered in this from Krishna?
As I said, we will be covering onboarding of the SD-WAN controllers. Then we will be talking about control plane data plane operations. We'll be talking about onboarding the fabric. We'll be talking about SD-WAN policies. These are going to be major topics that will be covered.
And okay, another, how this is different from Meraki Cloud?
Altogether is a different. Meraki is used for managing the wireless stuff. This is used for managing the WAN stuff. So both are different solutions and shouldn't be compared at all. Yes, we are going to cover the certification topics only. The content is purely based on the exam blueprint. We can get the security features into the SD-WAN fabric. That's correct, Manoj. Firewall and IPS and filtering, all of that can be implemented for sure. Sheshagiri, there is no relation with NSXT. NSXT is a product from VMware. That is their own solution. One more solution is for managing the WAN side, and Meraki solution is for managing the wireless infrastructure of your organization. Mujahid, the vManage bootstrap file is basically used in order to onboard your vEdges. If you don't use them, then in order to build up the DTLS connectivity, you need to upload the bootstrap file or bootstrap config. Yep. All right, I think we're good. That's all I have to talk about in this particular webinar. I hope you guys enjoyed it, and I would look forward to see you guys on board in one of our training. Thank you so much for joining.